So now we know the photoelectric effect. Now let us go to the de Broglie's hypothesis. I believe he is the first physicist to get a Nobel Prize for his PhD thesis, and also I think he's a historian. He became a physicist, got interested into physics, and ended up getting a Nobel Prize. De Broglie hypothesis basically says that there is a wave property for all particles. And he not only mentioned that, I mean, I think the light is a wave or a particle has been going on for centuries. But eventually we know that it behaves both, right? Sometimes it's a particle, sometimes it's a wave. But keeping that aside for a minute, de Broglie says that the wavelength of that wave property of a particle is inversely proportional to the momentum of the particle. That is, the momentum P is inversely proportional to the wavelength, which is lambda, right? In other words, P is equal to h lambda. Again, h is the Planck's constant. And if you want to write this in a h dash form, and again we can write this lambda in terms of wave number, then this will be k 2 pi, and h dash is equal to h by, this should be, this is wrong, this is 2 pi by lambda. So if I substitute this, it's just going to be 2 pi by lambda into h by 2 pi and h by lambda. Okay. So we can write momentum is equal to the wave number times h bar, right? So the momentum is equal to h bar wave number. Okay. So now we will go to the crux of this Schrodinger's equation, which is the wave function, right? See, to derive the Schrodinger's equation, we take the plane wave as the wave function. So the wave function is described by the psi function. Psi of x comma t is equal to e to the power I k x minus omega t. Okay. So this is the wave function we will take to derive the Schrodinger's equation. Let's do some partial derivative of this. Dou psi by dou t is equal to kx minus omega t, right, into I minus omega. See, this is nothing but the psi equation, right? So this is psi of x comma t I omega minus, right? So we will need this equation, so I'm going to store it in our bank. Psi of x comma t by dt is equal to minus I omega psi of x comma t. Good. Okay. Let's do a derivative, partial derivative with respect to x. D psi of dx by dt dx is equal to, again we know psi x of t, this one, right, into minus k. Okay. Let's do one more time, second order, and I think it may not be obvious now why I'm doing this, why I didn't do second order derivative, partial derivative with respect to time, but I'm doing it for x. It will become very obvious very soon. So this will be dou psi by dou x into ik. So we know this is this, right? This will become psi of x of t, then ik square, which is I square k square, right? It's just nothing but minus 1. So this is minus k square psi x of t. Okay. So I need this, so I will store d psi x of t by dx is equal to ik psi of x of t. Then I will store this one too, right? Second order partial derivative of psi with respect to x is equal to minus k square psi x of t. Okay, good. Okay. Now, so we know this one, right? Let's say this 1, 2, 3, 4, 5. This is 6. Say from 3, right? So we know k can be written as p by h bar. So substitute, let's say this is a, substitute a in 6. So what that means is the second order partial derivative of psi with respect to x, right, equal to minus, say, p square by h dash square psi of x t, right? Okay. What we can do is we can write in this form p square psi of x of t is equal to, so this becomes h square minus h dash or h bar. I know I'm interchangeably using h bar, h s, but by this time I think you know what I mean when I say h dash. Oh, what's my x of t by dx square, right? Okay, so let me store this one too here, right? So p square of psi x of t is equal to h bar square, again the second order derivative. Okay. Okay, so let's go back to the basic Hamiltonian, which is what is the collective energy of a system, right? It is not just meant to be for a quantum mechanics. Hamiltonian of something means like what is the energy, total energy in the system. So, so when you say total energy, that is kinetic energy plus potential energy, right? That's a kinetic energy plus potential energy. See, from 2, right, we know E is equal to h bar mu. So if we find the energy of psi, right, it will become x of t h dash mu, right? Let's say we write this in terms of 4, in terms of equation 4, E of psi x of t is equal to, right? So this is basically the one I'm trying to write in that terms. So we have minus I, right, dou psi x by dou t. See, I mean, basically I'm multiplying, maybe I should explain, so that will be easy.